y1 of t equal e to the t sine t, y2 of t equal e to the t cosine t. And let these be two solutions of a second order differential equation, and we want to compute the Wronskian, which that will be the determinant y1t, y2t, and then y1 prime of t, y2 prime of t. So we'll replace these with the function. So we have e to the t sine t, e to the t cosine t, and then take the derivative of e to the t sine t. We'll use a product rule, and then we'll factor out e to the t. So this is the same thing as saying factor out e to the t and take the derivative of sine and leave it alone. So drop down the sine and then take the derivative of sine as cosine. Here we'll factor out e to the t, take the derivative, or leave the cosine and then take the derivative of cosine. It's negative sine. So that's the shortcut here. And then we're going to multiply the diagonals. So the first diagonal, we have e to the t times e to the t is e to the 2t, and then we have sine times cosine minus, and then we have e to the 2t sine squared, and then we're going to subtract that with the second diagonal. So we have e to the t times e to the t is e to the 2t cosine t. So then we're going to multiply that by sine, and then we're going to multiply that by cosine again to get e to the 2t cosine squared t. And now we're going to subtract. So notice the first two terms, or the first two here, we are going to cancel. So we have negative e to the 2t sine squared t minus e to the 2t cosine squared t. Factor out a negative e to the 2t. We have sine squared plus cosine squared, which we know that equals to 1. So this will just equal negative e to the 2t as our Wronskian.